Hello everyone, thank you for joining us for the fourth and last lecture of Configuration Management, a short course presented by Information Technology Professionals Association, or ITPA, and facilitated by IT Masters. My name is Guy and I'll be your MC tonight, and as always, Mike C will be your lecturer. Sorry for a slightly late start, just a few little issues on our end. Just some housekeeping before getting into things, as this is the last lecture for the course. Next week, from the 30th of May until the 6th of June, is the exam sitting period. This period closes at 11:59 on the 6th of June. Despite having the whole week to do things, we really do think it's best not to leave taking the exam until the last minute, just in case of technical difficulties. But yeah, just be aware you do have a week to complete it. The exam consists, or to attempt it, I should say. The exam consists of 40 multiple choice questions, which you will have 1 hour to complete. These questions are from the course content presented in Mike's lectures, and please note that the exam can only be attempted once. Therefore, do not attempt the exam until you are certain you are ready. In order to receive a certificate of achievement for this course, you are required to complete the exam and earn a 50% course mark between both the exam and forum participation points. A reminder will be sent out the day after the exam period opens, and if you do have any technical difficulties, like saying technical difficulties, please email us at shortcourses@itmasters.edu.au as soon as possible, and we'll get onto those as soon as possible. And don't worry, Mike will repeat the exam information at the end of this lecture, so you can hold your questions until then. Once you've completed the course, we would really appreciate if you took a couple of extra minutes to complete the course satisfaction survey quiz, the link for which is found underneath the exam information on the IT Masters course page. This quiz contains a few questions related to the content, course mechanics, and execution of the configuration management short course. We'll review your answers at the conclusion of the exam period, and your answers will indeed inform our attempts to improve at what we do. We find your feedback generally very valuable, and that it does help us make future courses better. So please do have a look at that. As always, feel free to get involved in the chat during the webinar, and I'll get onto as many questions as I can, or send the relevant to the course, to the content ones to Mike during the webinar. And with that in mind, please welcome for the final time, Mike.
Hello, and thank you for the intro again, Guy. Welcome everyone. This is week 4. As Guy said, it's the last webinar in this short course. We do have a small amount of administration, so let me just solve the technical issues here. We had some problems with the GitLab repository that's referenced in the exercise 2, and which you will also need for the week 3/4 exercises, which are still not released because I have been working on them, trying to make them as not as easy but as straightforward as I can, and to rewrite them so that the people who do not have AWS access can at least try to do the same types of things on a different platform. We also have some catch-up slides, which is what we're going to start with this week. I had intended to record these separately, but it turned out that they fit into the flow for week 4 quite nicely, so I'm going to do those tonight. I don't think it will actually add too much time, if any at all, so let's get straight into it. One of the words you'll often hear used when people talk about configuration management is idempotent, and it's an odd-looking word. It's kind of a complex word, but it also has a very simple meaning. It basically means, if a system is idempotent, that when you repeat the action you just performed, you don't change the state of that system. Now, the easiest example of this is really going to be installing software. If you install a package and then straight away try to run that installer again, what should happen is that installer should come back to you and say, sorry, this is already installed, I've changed nothing. If you do that a second time, or a third time, or 100th time, the same result should be there. At the end of running that install, nothing has changed on the system. Okay. Now, obviously, there may be side effects when you try to run an installer. And one of the side effects that you might see is entries in a log file. Some people would argue that, if a software install added a log entry to a log file, that it wasn't truly an idempotent action. I think in practical terms, if it doesn't actually change the operation of the system, if it's an incidental side effect that doesn't have any other ongoing effect, then we can treat this as an idempotent action. There are some really good examples of idempotency just on the command line in Linux. When you type or cat the file, show me the contents of a file, or type file.txt on Windows, that doesn't actually change the system. In fact, it doesn't change it at all. And that's a special version of idempotence called nullipotence, or what a lot of systems people call a nullop. When you change permissions on a file, if you're not allowed to change permissions and it doesn't work now, it won't work the next time. In fact, that's nullipotent as well. However, if it does change the permissions, the first time you run a churn or a chmod or a shackle, then the second time you run it, it shouldn't have a different effect. The end result of running that command will be the same running it 3 times as if you'd only run it once. If you're looking at Ansible, probably the main example of idempotence, which requires a little bit of thinking, is the service module. When you have state equals running, if you apply that service module to a machine, to a managed node, Ansible will start running the service if it's not already running. And if it is already running, it'll do nothing. It's a classic idempotent operation. Ansible goes to a lot of effort to be idempotent. And it does so because it's really important for consistency. We'll talk about that in a moment. There are some operations that are pretty common that you'll find in any any configuration management system that are not idempotent. Appending a line to a configuration file. If you run this once, you'll now have a configuration file that's got an extra line in it. If you run it a second time, you've now got 2 extra lines. And whilst that may not affect operation, it's going to depend on the system you're using, it's not an ideal thing to have happening. Similarly, if you kill a process managed by systemd, the next time you go to kill that process, it's not going to be there. Right? If you try to kill process 100, systemd doesn't restart that process with the same process ID. It can't. That's a kernel thing. So the next time you go to run kill 100, you're going to get a different result. Now, it may not be material to the operation of the system, but it's not ideal. Other actions that may or may not be idempotent when you think about them: removing files. If you remove a file once, when you go to remove it a second time, it should still be gone. Your RM should fail unless you've told it to ignore the failure. Similarly, when you install software, even though I use this as an example of the obvious idempotent example, even when you install software, it's possible that a second installation could change the system in a material way. For example, if you were to use Yum and install Ansible, and then you come back an hour later and run the same command, it is entirely possible that the Yum cache has been updated in that period. And Yum will install or download a new cache. It'll say, oh, there's a new version of Ansible, and it'll overwrite the version that was already there. Now, that's probably what you wanted to do, as long as your policy is run the latest version of software. And if it's not, now you've got a problem because something unexpected has happened. The big advantage of idempotence is if you have an idempotent operation, it's safe to restart that operation. And in fact, you can extend that. It's safe to restart a sequence of idempotent operations because the ones that have already run up to the point where it broke will run again and not change anything. The ones that were interrupted haven't changed anything anyway, so they'll run again and they will change things this time. And the future operations which weren't run before will be run now. This is great for state management. It means you don't have to remember the state of each step in your operation sequence. You can just rerun the whole sequence. On the other hand, it doesn't always work that idempotence is possible. There's an example in the notes which I only did myself a few days back, and it was confusing, very confusing to have my Ansible playbooks keep reporting changes, even though nothing had changed in the playbook. What it meant was that my playbook took an extra couple of seconds to run, and that's fine for 1 or 2 or even 10 machines. But for 10,000 machines, 1 or 2 extra seconds is now 10,000 seconds, which is a couple of hours. The other disadvantage of idempotence is sometimes it's not really obvious whether an operation is or isn't idempotent. So most people tend to assume that it is. And that's exactly the opposite of what you should do. If you're not sure, if you're not certain that an operation is idempotent, assume that it isn't. Another useful property that you'll hear talked about with configuration management systems is immutability. An immutable system is a static system. What you actually do to get an immutable system is you build it in advance, deploy that built system, and you never change it. If you want to change the system, you build a new one, ship it out, and switch to the new one. We see this all the time. Live CDs are like this, golden images, the things we used to install off in the old days. Firmware is a lot like this, especially if you've got settings held in the cloud. A lot of hardware appliances are really immutable. You don't get 1 or 2 programs to update when you upgrade your router or your firewall. You get an entire image and you apply that image. If you're using Google Cloud or Amazon, images and AMIs are really good examples of possible immutability. You don't have to use them as immutable targets, but you can. What you're trying to do with immutability is basically limit the amount of change that happens in production. If you're not able to change a production system in ways that affect that system, there's a much better likelihood that the system will stay up and available. It also forces you to do things a little bit differently. You have to test. You have to get it right before you deploy. If you do get it right, if you do manage to deploy these immutable systems, there's some amazing potential for improving security. You can tell when something has changed that shouldn't have because it's not the system you deployed. In fact, if you're very careful, you may even be able to deploy a large part of your system as a read-only image. That's kind of cool. If you have these images out there, it's possible to build machines really quickly because you don't have to do any post-configuration. You just say, give me another one of these machines. Or add it to the scaling group or the load balancer. These benefits don't come for free. You now have to manage your mutable systems, your images. And the reason you have to manage them, even more so than you had to manage your config management to target your non-mutable systems, is because these systems can't be tweaked. If you get something wrong with a version, you have to build a new one. So imagine that you have one server, which is a database server, another server, which is your frontier, and a middle application layer. If you get a mismatch between your frontier and your application layer, you're going to have a real problem. On the other hand, if you've kept the artifacts for your versions, you may be able to roll back. Maybe. What essentially happens here is your software gets versions and your images get versions. And you have to be very careful about release management with your images in much the same way as you do with software release. Okay, we have this interesting little slide that I just threw together. This is not an examinable slide. This is a tool to help you think about control and ordering. Idempotence and immutability are part of the whole ordering process. It's what do we do as we're ordering and what's our endpoint. What we're really worried about with configuration management is how much control we can exert over our end configurations. We've talked a lot about abstraction. We've talked a little, in fact, a fair amount about control and about sequencing, and idempotence and immutability really cap that off. I'd like you to think about the relationship between control and granularity for a moment. You may disagree with where I've placed the dots on this quadrant. That's okay. What I'd like you to do over the next week as you're prepping for your exam, even though we're not going to examine this slide, is ask yourself, where would I put these aspects of a config management system on the quadrant? Would I agree with Mike? Would I disagree, and why? In fact, there is one thing here that I would change. I'm not going to tell you what it is. I'm just trying to get you to think about abstraction and about order and the relationship between the two.
You tease.
There are no right or wrong answers. I am a tease. There are no right or wrong answers here. This is an exercise for you and self-reflection. Okay, let's take some questions.
And as usual, mate, quite clear. If it passes my test, like the guy coward technophobe test, it sounds like there's not going to be many questions. But Ian has sent in a comment about that very graph. If you can bring that back up, please. Software packages more implicit. I'd have said more explicit. For Ian.
Okay.
Is that the one? Is that the one you were thinking?
I'm not going to tell you what I was thinking is something that I'd change on reflection, but I will say this, Ian. I will say this. Scale becomes important here. If you install one package that has a bunch of dependencies that are then reused by a later package, where would you put that versus a single package with no dependencies? I think it's safe to say you'd actually have two different dots, or perhaps even two dots with a line between them. Right? This is a tool for thinking. Would I do software packages a little bit differently? Maybe. Originally, I just had a small dot and then I made it bigger. Yeah. I'm going to go with, I leave it in your capable hands, Ian. Very
helpful. Tully has asked why settings isn't strongly explicit. Do you have to be explicit? Don't you have to be explicit, I should say.
So the thing with settings is settings tend to be very specific. That's why they're towards the finer side of granularity. They also tend to be set explicitly. You generally have an actual settings value, right? What we call a ground truth. It's something that you have manually decided to set as it is. Files are a little bit different. You may find that there's a file that you do need, or you kind of get away without it. Templates you fill in, so they're a little more implicit. Services, you have to have them, but your control is definitely neither explicit or implicit. It depends on what you're doing at the time. I would argue that settings is more explicit. In fact, it's probably the most explicit thing we do with the config management tool is set an individual setting.
Alrighty, and all we've got left is Ian saying fair enough about what you were saying, installation order is important. Other than that, no further questions.
Look, this is not a perfect way to represent this by any stretch. As I said, it's a tool, a thinking tool, and I will not examine you on this particular slide. All right. So let's get on to orchestration. These little diagrams should be pretty familiar. We were looking at deployment models earlier on in the course. Orchestration is yet another word that has many meanings depending on who you speak to and what their particular positions are. From a deployment perspective, orchestration is really no more than saying we have some way of controlling at a very high level sequences of operations. In a sense, that's very much like configuration management itself, but it's not exactly the same. What happens with orchestration, and the clicker's not going to work now. There we go. Is that we're usually talking about things that are larger than just a file or a software package installation. We're talking about orchestration at a much higher level of abstraction here. We orchestrate groups of machines. We orchestrate services. Yes, you can argue, and it's a fair thing to say that config management really is small-scale orchestration. But generally, when we talk about orchestration nowadays, we do mean working with these larger abstractions. Now, the reason you need orchestration is sometimes you just can't do what you're trying to do within a particular CM tool. Ansible is great, but it's not perfect. There are some things that are really difficult to do with just Ansible. One of the reasons that the exercises use EC2 is because there are some things that are actually really easy to do with EC2 that are difficult to do in Ansible and VirtualBox without using something like Vagrant. So orchestration, at least to some degree, overcomes some tool limitations. There are also cases when there is knowledge that you can't actually codify in the policy. It's okay to say, well, we always start this system up before that system, and that's easy to put in policy. But what about all the exceptions? What about when you don't start system B first because it's a clean power down, and that changes things somehow? So you need to have some way of handling those edge cases. You might also be worried that your sequence or your operations are not idempotent. And so you want to take very explicit control and you want to gate sequences of steps together so that you don't get into the second sequence until the first sequence has been completed and is perfect. Imagine doing a large upgrade where you can't afford to roll back, but you can afford some extra hardware. What you'll usually do is you'll build in parallel and then flip the switch. Right, that's a great example of orchestration. You'll also orchestrate when immutability is not sufficient or easy to achieve. There are some cases where it's just not possible to have fix systems for a particular kind of activity, especially with upgrades. In those cases, you're going to orchestrate. You're going to use some system for controlling a series of config management tasks. Yeah. How do you shift load to another data center? Is it as simple as I'm going to route traffic? The answer is no, funnily enough. It's easy to inject a new route to say, all the traffic for this set of addresses, send it to this data center. That's great. The traffic gets there, but you haven't switched your monitoring over. So now you're going to have monitoring pointing at your data center A and saying, no data, no traffic, something's wrong. And this is probably not a good thing, especially when it's a standard thing that you do shift when you normally shift load to another data center. This is not as rare as you'd think. Netflix do this all the time. They have really, really good tooling to move data flows around. They do it for failure reasons, and they do it just as a matter of course. They move things deliberately to make sure that nothing breaks. If you know that something's going to move from under you, you go to a lot of effort to get it right. Another example of orchestration is, if you're upgrading a database schema, it's basically impossible to go back from a lot of schema upgrades. You can always migrate forward, but migrating back could have consequences. So you may be able to create a database snapshot using something that's outside the database, a file system snapshot with a QS database. How do you manage those operations? You use an orchestration tool. Similarly, if you're provisioning users across applications, you can't add a user to application 7 unless they're already been added to 2, 3, and 4. In fact, adding them is a whole different process. So it's kind of configuration management. It's definitely orchestration. Okay, questions about orchestration?
None so far. Perhaps we should keep going. If they do get sent in, I'll interrupt you. But we'll keep cracking along and
Okay.
maybe save them for the end.
No
Feel free to jump in, folks, and just any question you feel like. We're doing pretty well on time, I think.
Excellent. So I will say one more thing about orchestration, and this might get people thinking. Orchestration, if you make it a part of your standard daily operations, you are well beyond ad hoc and defined. You're heading up towards optimizing. And if you do this as just a standard thing, what you're going to find is a lot of what was previously complex becomes normal. And that's fantastic for reliability. It's good for reputation if you can let people know in a nice way that this is part of what you do. This is your job. And it's the kind of thing that really gets people thinking about how important it is to do things properly. It's usually only used, at least initially, on big projects. But when you bring those principles down, if you start thinking in terms of large abstractions and how you control them, there's a whole bunch of really easy wins that you can get. I'll give you one more for free. Disaster recovery is an orchestration project. It involves people, and it involves systems, and it involves a crap load of data. If you get it right, then your organization suddenly has a whole bunch of risk managed, mitigated, and not on the radar anymore. That's a good thing. Actually, I do see a question that's come up.
Yeah, May's sent in a question.
I'm gonna hit that now. So, Mayu, you've made an observation here. Orchestration involves creating machines and environments from script. Creating a machine is creating or is an abstraction. What you've done is you've taken an application and an operating system, and you've called them this thing, a machine or a whatever, a node. You don't have to limit it there. You can orchestrate the creation of machines. You can orchestrate the creation of networks. You can go bigger and you can go smaller. Another question has popped up here. I am going to leave that just for the moment. I will get back to you, Othman. All right, so I want to talk about just some of the other tools that you may come across. This is not to give you recommendations on the tools, but more to let you know about the types of tools that are out there and where they fit in the config management ecosystem. I want to start with a very simple tool. It's called Fabric. And what Fabric does is it allows you to run the same command on different machines over SSH. This is very similar to just having a script which copies the commands you want to run as a script to the remote machine, and then SSHs to execute them. But it's a little bit more advanced than that. Fabric allows you to do that in parallel easily. So you can scale out the number of machines that you talk to at once. Fabric will collect the results of applying those scripts and return them to you. And with a little bit of extra work, it'll tell you the machines where you got a slightly different result. The reason I mention Fabric in this class is not because it's a great config management tool. It's a bit fiddly. It's not even a really good just general system admin tool. But it has one big plus, and that's if you're in a team where it's been hard to get people to change what they're doing, you should have been able to get them to at least use SSH. This now gets you to the next step. It gets people thinking about operations across multiple machines, and it's easy to install. Right? It's a very natural next step towards something like Ansible or Puppet.
I'll stop you there. Sorry, Mike. Owen sent in a question. Is Fabric similar to Salt?
No. Salt can do what Fabric can do, but it takes a lot more work to get there. The thing with Fabric is it just does the one task. It's SSH to groups of machines. Run these commands. Salt can do so much more than that. So the thing with Salt is your Salt minions decide whether they're going to run a particular command. With Fabric, that decision is made on the host you're running with Fabric just by simply saying this host is in or this host is out.
Thanks.
Okay, there's another class of tools which I really like. And again, the reason I like these tools is because they provide an easy introduction of configuration management principles into environments where they might be a little more conservative. Compliance tools are effectively configuration management tools without the ability to change the remote system. What this allows you to do is collect information about a remote system, possibly apply some computation or some processing, and come out with an outcome saying, yes, this measures a particular compliance objective. This meets a particular compliance objective. All right, so if you're in a PCI environment, you could argue that having config management is enough to meet a lot of your audit requirements. But if you talk to a PCI auditor, If they know what they're doing, they're going to tell you that, well, just because you changed it to a particular configuration doesn't mean that you're complying when we ran it. If you can use a tool which is read-only, that argument goes away. And a lot of PCI compliance, unfortunately, is convincing your auditor that you're doing things properly. There is a problem here that you need to be aware of. Sometimes, if you were to use a config management tool in particular, you'll use it what's called a dry run mode, saying, tell me what you would do. And if you've got a sequence of operations and the first sequence would require a change, everything after that operation in the sequence is an unknown because you don't know about the dependencies. You know that there is an implied dependency, but you don't know for sure. So when you use a config management tool, using your existing policy in read-only mode, the results you get back are indicative only at best. With a compliance tool, you can take that a step further. You can actually code up and say, if this isn't here, then tell me about this other thing. So they're not exactly a CM tool with the changeability stripped out. They're a little bit more. I go with test infra. I'm playing with GOS. That is not a reflection on server spec at all. It's a reflection on the fact that I head towards Python and Go. Server spec is generally, well, it is Ruby, and I'm not a Ruby person by default. They're all exceptionally good at doing this. Something you might want to try in your organizations is have one person use a compliance tool and have somebody else write policy to the same requirements. This is kind of like unit tests, writing unit tests and programming. It's a good way to verify that your config management policy is actually doing what it's meant to do. The other thing with the compliance tools is because they're not doing any changes, they run really quickly. Server spec and test infra are both fast. GOS is super fast. It means that you can run these tools every couple of minutes. And that could be really useful in some environments. We had a lot of questions in week 1 and 2 about PowerShell DSC. I'm not a PowerShell person. I do a little bit of PowerShell. It's not my native scripting language by any stretch. But enough people asked about DSC that I've spent a little bit of time reading about it, and I've got to say, I'm impressed. It basically takes the same principles that we've seen in CF Engine and Ansible and Puppet, and it creates a domain-specific language using PowerShell. It's specifically targeted at Windows, but there is a Linux version. They've open sourced the actual code for this, and it supports both push and pull. It's configuration management for Windows, and it's been done really nicely. If you're a Windows shop and you're not using DSC, take a few minutes to have a look at it. I don't say this lightly. I'm impressed with what they've achieved. It's pretty easy to use too. You write your policy using their DSL. You save it as PowerShell. You run the PowerShell file, and the modules actually generate an intermediate file, which you can then deploy with a commandlet. It's really, really, really elegant. I've got examples in the handbook. All the examples for these tools are taken from the websites. I don't profess to be a guru in any of them, but the examples I've chosen are in there because they show how similar the tools are to each other, how they meet the principles we've been talking about, and that they're really approachable. We had a question about salt. I think the fact that I've got an architecture diagram for salt and the architecture diagram for fabric is basically server, a bunch of clients, and some arrows. I think that actually says a lot, Owen. Salt is a much more complex piece of software. You can run it with SSH, but to get the real benefits from Salt, the performance in particular, the low latency change initiation, you really need to run it with RabbitMQ. And that's a reasonable overhead on the Salt masters. It's not so bad on the minions. They're very lightweight. The way Salt works is it uses what's called a message bus. Now, a message bus, as Salt uses it, is a publish, subscribe, broadcast bus. You have a communications channel, and people listen on that channel for messages with a particular, essentially a particular tag. So if you want a change to be made on a Salt minion, that change must be put on the message bus. The message bus then publishes out to each minion that's connected, and each minion connects to a publisher. Now, I'm explaining how this works at a low level. At a high level, it really doesn't matter. It's just a way of pushing a request from a master to a managed node. Like Puppet and Chef and CF Engine, the decision on what to apply is made on the managed node, on the Salt minion. So the policy gets pushed to the minion. The minion looks at the policy and says, these parts apply to me. I'll apply them to my system. And when it's finished, the results are pushed back so that your Salt master has an understanding of the state of the Salt minion. The Salt language is based on YAML. It's actually pretty easy. Once you understand the purple parts, which is the first line in this example. In Ansible, we tend to use the name value a lot. Salt does something a little bit different. An unindented line doesn't need a name marker. It is just the line. So the ID, the name, if you like, for this particular grain is clone the Salt stack bootstrap script repo. The whole thing is the unique ID, and it must be unique. After that, you have a list of modules and the functions within that module. So to install a piece of software, you would use the package module, and you'd use the installed function, package.installed. And then you'd give a list of arguments. Looks very much like Ansible, just a little bit different, and not too much different. Now we go to Terraform. Sorry, so where does Salt Stack fit in the ecosystem? It's both push and pull, depending on how you use it. It scales out quite nicely. It has some very particular behaviors. It uses a standard language format, YAML. It doesn't have a DSL. And it's fast. It really is amazingly quick to push changes out, or at least to initiate the changes. And because of the feedback loop that we have with a job and a result, you can actually do quite a lot of orchestration with Salt Stack. A lot of higher level orchestration. It's kind of cool. Terraform takes the view that, well, everyone else has figured out how to configure a machine. We're going to figure out how to provision machines, how to provision all the resources that we need to build a modern application. In other words, Terraform will let you request machines, build images, make network changes. It's up to you to actually configure at a lower level of finer granularity. The workflow is pretty simple. In fact, Terraform goes one step further and does something really neat here. Terraform has its own concept of state and of resource dependencies, and it allows you to look at what changes would be applied to a particular configuration. So you create your config files. You then tell Terraform to get the current state, update to the current state, just in case something's changed. You then run a plan, which looks at what the resource dependencies are and tells you what it would do. You can have a look at those in the graph. And then you can actually apply the changes if you're happy that this should go ahead. So most of the time, you're going to just say yes. But the fact that there's a human in the loop here, it's a deliberate design decision within Terraform. And given that they're operating at the orchestration level, that's a good thing. So this is, again, taken from the example that's online. And the full set is underneath the slide in your notes. But Terraform, when you run the plan command, will tell you what it intends to do. And if you have a look here, you'll see a bunch of settings for an AWS instance. And Terraform has come back and said, computed. In other words, I don't know what this is going to be. I will figure it out. Now, why is that useful? Because if you make a change and then you replan, now what Terraform does is it says, okay, here is the plan of changes that I'm going to make to this infrastructure. In this example, it's going to change the AMI, the image. It's going to maintain the availability zone. Now, this depends on the particular provisioner that's in use, right? The behavior of these depends on what you're actually doing at the time. And the behavior of the AWS provisioner here is maintain the status quo, don't change anything, keep as much as you can from the previous deployment. So in this particular case, the availability zone will stay as US East 1A. Right? You'll notice that the T2 micro, the instance type, stays the same, and it tells you that it's staying the same because it knows what the new one will be. If an IP address changes, that will come back as computed. And that's really handy because you can then say in your TF files, give me the new value of the IP address and use that going forward. Now, you can do the same types of things in Ansible, but you have to save the results of previous runs, and you then have to figure out what structure of data that module saved the result in so that you can get to the data that you need. And it changes because there's no standards within Ansible for returning data from modules. This is a big win for Terraform. In fact, I'm going to go out on a limb here. Of all the technologies we talk about today, I think Terraform is the one that's going to make the most difference in the next, probably in the next 2 or 3 years. Containers have already made a difference, and we're about to talk about containers. Unikernels will make a difference, but Terraform is the one that we're going to use because we can use it today. And we can You use it across the different providers that are out there, across the different cloud providers, across different virtualization hosting platforms. It's immediately useful and it's easy to use. It's the one that you should keep an eye on. Okay, now that I've gone out on the limb, containers. Containers sound fancy and they're really not. They're easy. A container is basically a minimal application environment. It's the stuff you need to run a particular application. And it's bundled together. And it's bundled together in a way that you can run almost like a VM, but not exactly. You don't have the full partitioning that a virtual machine gives you. I hesitate to use the phrase, but it's almost a para-virtual machine. What happens with systems like Docker is you use operating system level primitives to group things together and say, don't let these groups talk to each other. On Linux, we use namespaces and process groups and separate network stacks. Now, the main reason that you need to understand that containers are not virtual machines is because you don't have pure isolation. You have a very high degree of isolation, but if you can crash the Linux kernel in a Docker container, the machine crashes. All the other containers that are isolated will basically stop working because the machine has crashed from underneath them. It's difficult, but not impossible to make that happen. The way containers work is really, really simple. You take a base image, you add files to the base, you do any customization that you need, and that could use Ansible or Puppet or DSC. You set up your network, and then you say start. That's it. You may want to take that container that you've just built and ship it out and run it somewhere in the cloud. But, you know, that's really just a choice of deployment location. Now, if you get this right, if you take your customized base image, if you squeeze steps 1, 2, and 3 together, what you now have is a single image where you don't do 2 and 3, and it's just a file copy. And because it's a Docker image or a container, it's quite lightweight. It's really fast to ship around. It's fast to copy. It's fast to start. And that's really helpful. You know, you can start a whole new machine in seconds. You can even do a really nifty thing and preload a couple of machines so that if you get a big load, you switch them in. And as you're switching them in, you say, give me some more Docker instances, so that you get rid of that initial latency. That's kind of cool. And finally, that gets us to Unikernels. Unikernels take that idea to a whole other level. A Unikernel combines your application, your library, and effectively your operating system into one single running image, an actual binary, effectively. It doesn't have to be binary per se. It could be a VM, like a JVM, but everything's in one place. It runs as one memory image. Effectively, you have now built a custom operating system. And that operating system is your application and anything that supports it. That's going to be really fast to deploy, really fast to start up, and it's going to be pretty secure. These are really good advantages for a deployment system. The hard part about Unikernels is actually getting them to work in your particular application. You know, you need to change some degree, depending on which platform you're using, you need to change how you develop. There may be certain things that you just can't do, and if your application requires those, well, you can't run as a Unikernel. These tend to be low-level things, like network sniffing and the like. The whole point of Unikernels is to strip things back to the bare minimum. Will they make a difference? They've already been making a difference. You just probably haven't really thought about Unikernels in this way. Think about router firmware. It tends to come out as one image. It's a little more kernel-y than Unikernel, a little more monolithic microkernels, but the same principles apply. Everything is built to a particular version. It's one image, it's shipped out. Okay. Question time.
Feel free to send them in, folks. Perhaps, as this is really your last opportunity, we'll get into the exam information now. Mike, what do you reckon? And then come back to questions if any come in.
Yeah, let's do that.
Oh, actually, no, sorry. Let's go back to Ottman's question.
Oh, yes.
What about the real fit of the software with the hardware? Long question, folks. I'll
Okay.
let you read it, Mike, and then get into it.
And then I'll paraphrase. Okay. So I'm going to try to repeat your question, Othman, in a little bit different terms. You're asking, is orchestration enough if the way your software is being built doesn't have sufficient consistency? So let me take a step back for a moment, just 2 or 3 slides to containers. If you have a container for deployment, that container, just because it's a container, doesn't make it secure, doesn't make your application reliable. What it does is make your environment consistent to the definition of the container. So, in the case of Docker, to the definition in your Docker file. All right. This is just a way of packaging software together with a lot of the support files that it needs. The plus of using a container is, from an operations point of view, you don't care what's in the container, really, because the developers are going to give you a container and you're going to be able to deploy that container. Right? The responsibility for what's in the container eventually falls on the developer. From a developer point of view, you also don't care, because you can put whatever you like in that container. And unless the networking agrees with what Ops has set up, you're not going to get data. So Ops will be happy. You'll be happy because you control the environment. Now, if you take what I've just said as reasonably true, that container is now a black box. So when you want to provision, it doesn't matter whether it's a good black box or a bad black box, because you're going to provision it anyway. So your orchestration tool, whichever tool you choose, as long as it can push a container out to your deployment platform, it doesn't care what's in there. Now, that's the practicalities of it. The theory is you shouldn't be deploying garbage. Unfortunately, your theory is not always practice, and garbage happens. Does that help, Othman? I guess what I'm saying is that your orchestration tool works at a higher level of abstraction. And that says nothing all about the quality within the abstraction.
And yes, it does for Ottman. Thank you.
Excellent.
Couple of questions. We'll start with James. Forgive the newbie question, but not being a Unix shop regarding containers, what is a Docker? And don't apologize, James. That's the sort of questions we like here.
Okay. Docker is a container system. It's a combination of a language for specifying how to build a container and the infrastructure for running that container. So you can run Dockers on Windows. You can run Dockers on Mac OS X. Think of them as kind of like a very lightweight VM image, but they're not a VM. Does that help?
Well, that's coming in. Yes, it does. Thanks from James. From Rod, does Terraform use Ansible scripting with YAML?
No, Terraform is its own language. You can use Ansible within a provisioned service if it's a machine that can run Ansible. Terraform doesn't care what CM system you use within the machines. All it cares about is making sure that the machines are there for the CM system to use.
And Maya's asked, containers aren't environment specific. There's no configuration there.
Maya, you can parameterize your containers so that you have to give them certain settings when you start them up. The containers themselves include enough binaries generally to run. The usual assumption is that you're running Linux. I've never actually run Docker on Windows, but I am assured that you can make it work.
Alrighty, and there's a question about the Mark for Forum involvement, which I'll just knock on the head now and say there's a lot of information at the learn.itmasters.edu.au page in the forums in week 2, I believe it is. But the idea is because the exam is 40 questions, if you were to participate in each week's forum, then you would theoretically get 4 points, and that could contribute up to 10% of an exam mark. So if you were to get, say, 40% and had participated in each week of the forums, then that would bump you up to the 50%. And other than that, I'll let Mike get on to the ins and outs of the exam.
Yep. Okay, it is open book. The exam is an open book exam. You can go out to the internet, you can look at the handbook, you can look at the forums, search the forums. I don't care. I'm not grading you on your ability to memorize. The questions, some of them are very easy. Some of them are a little less easy. There's a few questions that require you to think. It's difficult to set an exam for 2,000 students. Very difficult. So, I'm not going to make the exam hard to pass. It's probably 60% written right now. We'll finish writing it in the next day or so. All the answers, all the questions are some form of multiple choice. There are some true-false questions, which is a multiple choice between true and false. There are some choose one of these answer type questions. There are also a small number of choose all that apply, where If you get all of the ones that apply correct, you'll get 4 marks for the question. If you get some, you'll get partial marks. If you get a wrong answer, you will be penalized. And as I said, there's not a lot of those, but I think there's 5 or 7 of them. A question that has come up on the forums as well is, do you need to be able to write Ansible? And the answer is absolutely not. You don't have to write any Ansible. You just need to choose answers that are in multiple choice questions. You will need to be able to read Ansible. I'm not going to make this difficult. It should be obvious what is in the Ansible. But yeah, you do need to be able to read Ansible files. As a very rough guide, there are 10 questions associated with each week of the webinars. You think?
Hotman sent in a question about Sandbox. Can we compare Sandbox in the world of Windows, especially SharePoint, with container in Unix?
So, given that I'm not a SharePoint person, it's the same kind of principle. It's an area with limited interaction with the rest of the system, or well-defined interaction and isolation with the rest of the system. That's close. If you've looked at the virtual env for the exercises, a virtual env is very similar in many respects to a container. Things that you run in the container can only talk over the network to things that are outside the container.
Alrighty. No more questions on my end. Just a couple more slides to go.
Okay. Yes. Just a couple. So let's do these. Change screen. I have learnt things taking this short course. This is a slide that Guy has not seen before. Surprise, Guy. And these are my learnings for this short course. You're welcome. Things I'd probably do differently the next time I ran this short course. I'd use VirtualBox instead of AWS. The minus for doing this would be there's no cloud experience. But the plus is you can do it all on your own computer. It is a trade-off. I don't think that I made the wrong call using AWS, but I also definitely didn't understand the potential problems with doing so. I'd also add an optional intro to Linux session. We call it week 0 or possibly another short course. Instead of walking through the Ansible code live, I definitely record that next time because then I can actually use some of the highlighting tools that are out there, and it might make it a little bit easier to just go back and forward through the code. I would also add more Windows examples, just given how many people are working with Windows. The DSC tonight was a part of an attempt to try and at least partially address that. I do want to say that I have absolutely enjoyed reading the forums and teaching this class. There's some amazing discussions on the forums. After you finish your exams, please go back through the forums and read some of the longer discussions. They are fantastic. I'm being forced to think about things. It's phenomenal. I spent 8 years lecturing at a university, and I can honestly say that the discussion that's happening on those forum topics is university level, and you should not waste the opportunity to contribute and learn. I also want to just thank you all for spending 4 weeks of your time listening to me. A very special thank you to Mia and to Guy for helping, and the IT Masters team. And another special thank you to probably a dozen students, 12 students or so, who have been above and beyond discussion. They've been helping discussions and other students on the forums. It's fantastic to see that level of support of your professional peers. And just thank you very much for doing that. And on that note, thank you all very much. I hope you make
Love it.
best use of configuration management.
Yes. Yes. Oh God, I love that. Yeah, I can only reiterate what you've said, Mike. That's it's been really really great reading those forums. So I suppose all that's left for me to say is also to thank Mia for her support during the course, and also Robert from ITPA, the president, for coming in for his presentation in week 2. A big thanks to you, the students, for helping to make this short course interesting through, as Mike was saying, your attendance and participation. And of course, Mike, big thanks must go to you for taking the time to develop and really develop this course, and really spending your extra time answering questions. It's been really great, and I can't thank you enough for that on behalf of
Awesome.
IT Masters and also, I suppose, the students. Been a pleasure. I might leave you to have the last goodbye. And
there will be week 4 exercises. Week 4 exercises. Week 3 has been moved into week 4. Week 4 exercises will issue. You will not be examined on the week 4 exercises. They are for your learning only. So relax. I know a couple of people have been like, where are my exercises? Which is fantastic to see. And I will be following the forums. And I will do so for a week or so after the exam period closes as well. Just if you have any questions afterwards. Thank you everyone. This has been a blast. It's been very cool.
Thanks, Mike. Thank you. Everyone, please do remember to complete the course satisfaction survey. Good night to you all. And of course, good luck with your exams. We look forward to hearing your feedback.